Welcome to qnawire.
Okay, so 65 says an airplane is delivering food to a small island. It flies 100 meters above the ground at a speed of 160 meters per second. A, where should the parcel be released so it lands on the island? Neglect air resistance. And then B, simply estimate whether you should release the parcel earlier or later if there is air resistance and explain this. So you're 100 meters above the ground, traveling at a velocity of 160 meters per second, and simply you just assume a projectile path as the thing drops. Okay, so for part A, let's just quickly do this. We have in our x direction and y direction, let's just solve a few quick SUVAT equations. So I like these. These are just quick ways of figuring out what's going on. So, firstly, if we're trying to land on a small island, we just need to have some idea so that we will drop and hit a target. So how much sooner than the target do we have to release? The question is, how far will the thing go? So if s is the distance that things have to travel horizontally, that's our first unknown. But we do know horizontally that we're traveling at 160 meters per second. And likewise, there's no acceleration horizontally, so we continue to travel at 100 meters per second with no acceleration. And our time, as of yet, is unknown. Our distance that we have to travel vertically is down by 100 meters. We have no initial velocity vertically, and our final velocity may not matter, because we're accelerating down at the gravitational constant 9.8 in a downwards direction, hence the negative. And of course, we don't know time either. So let's solve the vertical equation first. What we do know is that s, our distance traveled, is equal to ut plus half at squared. But there is no initial downwards velocity, so this term is simply equal to 0. And therefore, substituting in values, minus 100 is equal to minus g over 2, that's half of acceleration, multiplied by t squared. And so it shouldn't surprise us that t, time taken to drop, is the square root of 200. We've cancelled out those negatives and brought the 2 to the other side, divided by 9.8. And we put this into a calculator to find a time of 4.518 seconds. Good. And then we simply have to work out how far the thing will travel in the x direction. So in x, we simply say that the distance we travel is equal to our velocity multiplied by the time it takes to traverse that velocity, which means that our distance traveled is simply equal to 160, our velocity, multiplied by the time we just worked out, 4.518. And hence the distance it travels is 722.8 meters. And what this means is that we simply have to release the package 722.8 meters sooner than if we were on top of the island. So this distance here is 722.8 meters. And that's when we have to release the package in order for it to land on the island. And question B is just a little bit trivial. Basically, it says the air resistance is involved and estimate whether you should release the parcel sooner or later than if there is air resistance. Well, air resistance is some sort of force of drag or slash air resistance, AR. Well, this is proportional to velocity squared, and we are going very fast in the x direction. Very, very fast in the x direction, to the point where even if we take g and multiply it by the time it takes to fall, which is, we can round that 4.5 up to 5, and say that we could be traveling at most at 49 meters per second down. The vast majority of decelerating force is coming from the x direction that we're traveling in, that we're slowing down far more because we're traveling a lot faster horizontally. So we're constantly slowing down in the x direction, so that means that the package will fall with a much steeper path because the air resistance is pushing us back as we're traveling with that velocity, which means simply that less distance required if air resistance is present. Okay,